Okay, thanks. So I'll talk about some of the work that has been done by my colleagues. I'll cover three quick areas. Vivek just talked about the Bhashani. Uh, okay. I view that as really important because, again, those of us in this room, we are the privileged ones who understand English. There are hundreds of millions of, again, people in India who would prefer to get access to information in their own native language. Let's say that laborer's daughter in Chhattisgarh or the farmer's son in Haryana. So how do we provide them? Do we democratize that access to information and then health and agriculture? So the good news is that today, you do not need to, the problem of languages is now becoming much more tractable to solve. You do not, traditionally, what AI products used to do was take one language at a time and kind of build automatic speech recognition, text processing, and so on, right? Those kind of capabilities. Increasingly, you are having this ability to build a single model that is able to handle all of the different languages. So our journey started with this first model called Mural that we built, that at that time was providing the largest coverage of Indian languages, 16 Indian languages and English. And we saw a very significant difference in the kind of improvements that it led to on various kind of natural language processing tasks. And now what we are doing is we are raising our ambitions much further. So one of our projects is Project Vani, together with Indian Institute of Science, where we are collecting speech data from every part of India, from 773 districts. Our plan is to collect speech data and put all of that data back into open source so that the research community, the practitioners, and anybody, students, they can all make use of this data, not just us. And the power of this kind of data can be seen from even some trends that you're seeing. So Google recently announced this model called USM, Universal Speech Model. There's a single model that covers over 300 languages. It is able to recognize speech in 300 languages, just that single model. But the fact remains that many of these models still do not have very good coverage of Indian languages. So which is why collection of data, again, that is truly representative of India is really, really important. So again, the Mural team is now working on a different project called Morni, where we are, instead of only sticking to 16 Indian languages, we are now looking at over 100 Indian languages. So if any language has at least 1 lakh speaker, we want that language covered in the multilingual models that we build. And this is part of a bigger effort that we refer to as Language Inclusivity Moonshot or 1,000 Languages Initiative at Google, where we are also, our team is also trying to come up with the recipe of how you would build a single model that will cover over 1,000 languages of the world. So that all of these kind of so-called tail languages, right, which represent communities that may not have that same economic clout as English speakers, they get their voice too. And now coming back to even English, the English that we speak in India is actually a superset of formal English. Look at this appetizer menu of a restaurant. So we looked at this as inspiration for our work, that I don't want to think of that appetizer word as a misspelling. I want to, because if you truly look at how it has been spelled, phonetically it makes sense. And B, there's a certain native language influence that has led to how it has been spelled. So I want to understand the user intent. And I want the AI models to be able to handle all of these variants. So, and in fact, for us, it's a real problem. I mean, it's not an artificial problem. There are queries like this that appear in Google search, and we want to understand all of the intent of those queries. So that led to this project called Indophony. Actually, the concept is very broadly applicable beyond India, that if you can really model the phonetic, the spelling variations and pronunciation variations that are driven by our native language influence, we could do a much better job. So So now we could kind of represent that. Okay, so I'm out of time. So very quickly, in areas like health, before we start applying AI to health, we first need to get that health data in digital form. And this is where we are trying to, because so many of our healthcare providers continues to use paper-based prescriptions. So our first job is to digitize or capture all of that data in digital form, where we are again developing, and we realize that just standard OCR technology doesn't work. You need to combine OCR with the modern language models and so on to be able to tackle that problem. And finally, in agriculture, again, we believe there's an opportunity for us to tackle many of these problems in a very scalable manner. And we take inspiration from all of the wonderful work, for instance, that has been done by the Aadhaar team, by the UPI team, and so on, that just like they gave a unique ID to every individual, can you give a unique ID to every field in the country through satellite imagery analysis? Start with that, and then can you start to identify all of the crops that are being grown? Can you start to identify important events like like sowing, harvesting, stubble burning? And can you then, for instance, identify it, all of these activities right at the field level, so that now you can play the usual policy things of, let's say, incentivizing farmers to avoid burning their stubble financially, directly transfer money, and ultimately even incentivize regenerative agricultural practices. Because we know many of these regenerative practices will increase the carbon holding potential of soil, and if you could model it credibly, you could actually incentivize the farmers even financially. So these were just a few sample examples of where AI can make truly a transformational difference. And we are really excited about the future and again, working with the community and partners to ultimately make all of this work. Thank you.